Hi, this is about artificial intelligence, and I'm going to do a video on artificial intelligence through my channel, AI Nexus. I'm Dr. TV Geeta, and in this particular video, we're going to talk about supervised learning and how AI learns from data you give it. How AI learns from data that you have given it. That is called supervised learning. Supervised learning. Is a type of machine learning, and types of machine learning are generally classified based on the type of feedback you give it. In supervised learning, you're given training data which consists of both the input and the correct output, or the labels as it is known. It's like a teacher giving the input and the correct answer, helping you to train. Now, this is an example of supervised learning where you have label data, which are images along with the labels. The three types of data images we have here are zebra, elephant, and bear. And now this label data is given to the model, and model training happens, which does a mapping between the input and output, and that is the use for prediction. So in the prediction, you're given after the prediction model is built, you're given the test data, and the prediction happens, and the predicted images along with the label is given. Now the model learns a mapping from input data to output data, which we call as function of x, the input data, will give you y, which is the output data. So you actually compare the predicted output and the true output, which is also given as input. Remember labels, and you use that to minimize the error, and you get the output as a predicted output. Now, feedback here is direct and immediate. It's like a teacher telling you, correcting your paper immediately and giving you feedback, so that your mental model is modified so that you can make better predictions in the future. The important point about this is it's having a strong feedback, so faster and more controlled learning happens. And because of this labeled data, it works very well. It has got strong guidance, clear objective, and evaluation can be done effectively. Only problem is there is a chance of overfitting happening, because the mapping between the input and output can be exact. So that is one problem. Now, supervised learning, as we already told, we give labeled input data, that is input and output together, and the supervised learning algorithm will learn a model or a hypothesis. Then the model makes a prediction from the new unseen input, and the predicted output and the two output which will be available are compared, and loss is calculated, which gives the exact error magnitude as well as direction. And this is used to modify the model by adjusting its parameters such that the loss is minimized. This is the effective explanation of supervised learning and how it learns. So some basic questions persist. What is you want to predict? That is, what is the output you want? How do you give the input? Okay, and how do you prepare it? How will you find out what the target function looks like? How to find that target function, and how we evaluate that? So these are some of the questions that exist when we talk about supervised learning. Now, let's take a real world analogy. Let's assume cooking, given the recipe. So the recipe is the input, you cook it, you make a dish. Immediately a taster is available who gives feedback. Okay, that is the Y. And you have to add seasoning, change the cooking time or the cooking technique, which is called as model update, so that finally you get a perfect dish. This is a real world analogy of supervised learning. Now let's try to understand machine learning, in this case supervised learning, a little better with a simple toy example. It can be only considered as an example for learning and conceptual understanding purpose. So you're given data. In this case, we are taking it cannot be used anywhere as one-dimensional data, X. and you're also given y. So the input is given and the output is given. Normally you must remember that each data point here, we are assuming n data points, assume each data point d1 here is one dimensional, but actually it can have many dimensions depending upon the number of features that are there. Okay, so that is the first step. Then comes the model. Now, selecting a model has to be done by human beings. It is not given by the system. In our case, we assume a very simple linear model. In our case, it's a straight line linear model, and learning actually is about fitting this linear model to the data points. Okay, training data, and here the learning parameters in our case, if it's a straight line, are slope A and B, which is the intercept. It's nothing but high school maths. So the model is y is equal to ax plus b. This is what you've got. And you have to choose the a and b in such a way that it fits. Now, how do we choose that? What helps us to choose that? That's the next step. So you have to choose an objective function. Here we mean an error function. Here squared error is what we have shown. So here you have y of y, the true value of the output, given a value of x. And then you have given the model, what does the value give? The difference between this is the error. The square of the distance between this is the error. Now the actual learning happens. What happens? You find the set of parameters, in our case the slope and the intercept, such that you have minimum error. The smallest error is obtained. So you have chosen the model. It's a linear model, but what you're doing is you're choosing the parameters of the model such that it minimizes the error. Once you do that, the next step is testing. So given an unknown x, okay, you have to project it onto y such that on the line such that you get the value of the output. That's how you test the model. So this is an example of supervised learning, machine learning also, and supervised learning, because the true output is given to you. Okay, and you're predicting an output, comparing the two and minimizing the error so that you get a model with appropriate parameters. So when you're given new data, you can use this model to predict the output. So that is what we have learned here.